All right, before we get into this, I would need for you to make sure to watch the Science Guys video I provided first. They have the great ability to show physically how these gas laws work. So I want you to watch that. It's pretty brief, but and they're kind of goofy, but I like goofiness. And they bring home the point very, very well. So please watch that before we get into this. Okay? Now, Boyle's law is the relationship between pressure and volume. And one of the things the science guys talk about is the inverse relationship. In other words, when they increase the pressure, made the p-value bigger, the volume got smaller. So as one goes up, the other goes down, or as one goes down, the other goes up. That is called an inverse relationship. Now, I'm going to throw some mathematical terms at you. It's all going to resolve itself to a very palatable equation for you to use, or formula. But bear with me on this. An inverse relationship, P, and then this is a symbol that means is proportional to. Now, because you want to show that as one increases, the other decreases, instead of putting a V here, we put a 1 over V. Okay? So the relationship is inverted by showing this one of these two variables being a fraction. Now, when you have a proportionality constant or a proportionality relationship and use that symbol for that, we can change that into an equation by replacing the alpha or proportionality symbol to an equal. But when we do that, we have to have a number that's going to correlate those two variables. So we use the letter K. Now why K? Well, we are using the Germans were really big into coming up with these mathematical relationships. And so the mathematicians tended to go to the K, which stood for constant. The German word for constant is constant, but it begins with the letter K, so that's why we use K. Anyway, times 1 over V. So what is the constant? Well, we don't want a number here that is going to change depending upon what our conditions are. So what we're going to do is we're going to rewrite this equation right here so that the constant is by itself. So what I'm going to do here is I'm going to multiply both sides by V. And that's going to cancel that out right there. And you're going to be left with K here. And here we got two variables multiplied together. Generally, and not always, but it's not a hard set rule. But I like to put my variables in alphabetical order. So we're going to put PV equals K. Now, what is pressure? What is volume? Well, whatever the relationship is in this set of conditions, you're going to multiply them and get the same number every time. So K is never going to change for the set of conditions. Now when I say conditions, same pressure, same temperature, not same pressure, same temperature, and quantities in a certain measurement, but we're going to have the same conditions. So I'm going to take a scenario where I start with a certain pressure and volume in dealing with gases, and I get that K. And then I'm going to change the pressure, which is going to change the volume such that you have a second pressure and a second volume, but when you multiply that, it has to be equal K. By definition, a constant means you cannot change at all. So you can have different values for P and V over here as compared to over here, but when you multiply both of them, they must equal K. Now there's something in mathematics called the transitive property. The transitive property basically states if A equals B and B equals C, therefore A equals C. So that means since these both equal K, then P1, V1 equals P2, V2. And that is our quantitative definition of Boyle's law. Okay? Now, quantitative means math, quantity, to deal with quantities. There is what we call a qualitative definition, which I kind of talked about up here. I'll put it on here for sure. And that basically states that as pressure increases, volume increases for gas. Now we're talking all gases. And does it make any difference as to which gas we're talking about? The answer is no, because gases, and we call these ideal gases. Ideal gases are those gases that when they collide together, they don't create a reaction. They don't stick together, or they don't break apart and fall and create new substances. These are ideal gases, and ideal gases all behave the same way for these gas laws that we are assuming. Okay? Now, this is called the qualitative definition. And the qualitative definition is basically a statement in words. Now, we could also have replaced the word increases with decreases. And the law states the same thing in either terms. Now, a law is a description of a pattern of a behavior of whatever quantities you're looking at. So, gas laws are simply descriptions of behaviors when certain conditions change, and how we can formulate a mathematical formula like P1V1 equals P2V2. So let's take a look at the two examples I provided for you in this discussion. First one, we had 54.5 liters of a gas. I don't remember the gas, and it really isn't important what gas it is, at 1 atmosphere pressure, but then we changed the pressure from 1 atmosphere to 13.3 psi's. Now, here's the deal. The pressures must be, labels must be the same, and the volume labels must be the same. Well, this is not going to change here, but you see the two pressures here. We have two different values. And generally I find, and it's up to you how you want to do this, but I generally find it's a lot easier just to take the definition of 1 atmosphere and plug it in here. And we had talked about how 14.7 pounds per square inch is the equivalent of 1 atmosphere. And we're going to use that in our equation of P1V1 equals P2V2. So this is going to be, first pressure is 14.7 psi's times the first volume, 54.5 liters, equals the second pressure, which is 13.3 psi's, times V2. And this is just your basic algebra problem that you guys are old pros at now. Just simply divide both sides by 13.3 psi's. And I strongly advise putting labels in the settings for these things to show you why the label for your answer is what it is. This cancels out because that's what we divided by. And you notice that psi is going to cancel out right here. And you know that your volume has to end up in liters. Now I know that's pretty simple sounding. Yeah, why do I need to put all those letters in there? Letters hurt my hand when I put too many on there. You're trying to hurt me, Mr. Campbell. Well, put them in. Because I find that students are going through the motions, not really thinking about what they're doing. And when that happens, you come up with really weird answers like, I thought pounds was a measure for volume. Trust me, I've seen that happen. So, you go ahead and work this out. Again, I went 3 significant figures in the answer, and we get 60.2 liters. All right, second example that we have here. We had 800 cc's at 750 torr, and the volume goes from 800 cc to 1 liter. And the question is, what is the new pressure? Now, what I should have done with the previous example is talk through that a little bit. I'm going to do that here. When you see the volume go up from 800 to 1 liter, what's going to happen to the pressure? Well, like we said, it's an inverse relationship. We know that if this goes up, then this has to go down. So we're assuming, and we're going to prove it to ourselves, that the pressure is going to be something less than 750 torr. Let's find out, shall we? Ooh. So P1V1 equals P2V2. You have to keep writing that down. I'm going to say, yeah, just to help get it ingrained or cemented into your brain so it will come to you very quickly. If you're part of a group that's going to be taking the test on that, that's going to be really important on this when you take your test over this chapter. The first year students doing this don't have to take the test this year. They got lucky. The rest of you, not so much. So, first pressure, 750 torr. Times. Now, here's another thing we got to look at. Our volumes have different labels. This is in cubic centimeters, this is in liters, and I also find that, again, this is by definition, if it's just plain flat out there as a definition, that's the easiest one to use. So we're going to change that to 1,000 cc's and plug that in when we get to V2. But V1 is 800 cc's equals our unknown second pressure times 1,000 cc's. Okay? So again, a basic algebra problem here. We're going to divide by 1,000 cc's. Again, keeping the labels in our setup, and any changes that we have to make, that cancels out 1,000 cc's. That's why we divided by it over here, multiplying on the right, dividing on the left. And the cc's are canceled out because they're both found in the numerator and the denominator. And we multiply 750 times 800 divided by 1,000, and our second pressure turns out to be 600 torr. And look, this is we predicted. If the volume is going to go up, the pressure has to go down, and it dropped from 750 to 600 torr. Okay? All right, practice problems. Any minute now. Oh, hello. We have 5 practice problems for you. Have fun.